Solution to example 10 from notes 3.1 on quadratic functions. This is an application problem, and here we're asked to find two positive real numbers whose product is a maximum. When we're asked to find a maximum or minimum, this is going to be a quadratic function, and we're going to be looking for the vertex. That's where the maximum is going to occur. Then we're given more information. The sum of the first number and 3 times the second number is 42. And I said, be sure to define your variables. So first, we have two numbers. So let's let m equal the first positive real number, and we'll let n equal the second positive real number. So we're defining our variables. And then we're told that the sum of the first number and 3 times the second number. So we're going to write an equation for this. For the sum of the first number and 3 times the second number. So the sum of the first number is m plus 3 times the second number is equal to 42. And then we're asked to maximize the product. So we want to maximize the product. So the product is equal to m times n, and that's a function that we want to maximize. We want to get a function with only one variable. So for that, I can substitute in for m from the expression from the sum of the two numbers. So I can say, I'm going to solve this here, and I'm going to say this means that m equals 42 minus 3n, and then I'm going to substitute in here. So my product in terms of one variable is going to be 42 minus 3n times n. That's my product, we can say, as a function of n, as a function of the second number in this case. And this is the product that we want to maximize. It's a quadratic function, so the maximum occurs at the vertex. I can put this in general form, so P of n is going to be equal to 42 n. Let me fix that, sorry about that. So it's going to be equal to 42n minus 3n squared, and then putting it in the proper form, 3n squared plus 42n is equal to P of n. And we can solve this, find the maximum in two ways. So I'm going to first find the maximum, which I'll call method 1, and I'm going to find the vertex. The vertex, when I'm looking at an equation in general form, so in general form I had P of n is equal to negative 3n squared plus 42n. The vertex, or the maximum, occurs at negative b over 2a as our, in this case, n value. Or normally it's our x value. So the maximum is going to occur at negative b, which is going to be negative 42 over 2 times a, which is 2 times negative 3, which is negative 42 over negative 6, which is 7. So n equals 7 is where the maximum occurs. And when, let me fix that, that doesn't look so good. The maximum occurs when n equals 7, we can substitute back into this equation to find m. M is equal to 42 minus 3n, so that's equal to 42 minus 3 times 7, which is 21. So our numbers are 7 and 21. I want to solve this by a second method. So method 2, I'm going to use intercept form or factored form. Method 1, I should have written that down. This is using general form. General form. General form. In both cases, we need to find the maximum. So to find the maximum, when we're in factored form, we can take the average of the x-intercepts. So in factored form, we had, I'm going to divide this up. P of n is equal to 42 minus 3n times n. And this is in factored form. The maximum will occur at the midpoint between the x-intercepts. So maximum at midpoint of x-intercepts, or the zeros. So let's find the x-intercepts. We can solve 0 is equal to 42 minus 3n times n. So that means by the zero product property, 42 minus 3n equals 0, or n equals 0. Here we get 42 equals 3n, and we'll divide by 3. We'll get n equals 14, or n equals 0. Oh, sorry, I can't squeeze that in. Let me write this over a little bit so you can see it, or n equals 0, which means that the vertex, or the maximum, is at n equals 7, which is the midpoint between 14 and 0. And then once again, we get the same thing, n is 7, and then n will equal 21. Either way, we find that our numbers to maximize the product are 7 and 21. One last thing that we could be asked would be to find the maximum product. We're not asked that here, but if we were, the maximum product would be 7 times 21, which is 147. So I'll squeeze that in over here. If we were asked, the maximum product is 7 times 21, which is 140.